Okay, AP Stat, this is your second Unit 2 video, so I'm just working through the notes here for you just to give you an idea of what's going on. At the bottom of page 1, we do have to talk about one thing. What do we do if our data appears to be nonlinear relationship? Now, if I were to give you a set of data and ask you to graph it, sometimes you get a situation where you don't have a linear relationship. So sometimes what we can do is we can manipulate the data algebraically by changing the equation, like by taking the log of x or by taking the log of x and the log of y. So we can manipulate it algebraically to see if it doesn't, quote, straighten out our data or linearize it for us. Something else that can be done is breaking the data into sections and just looking at the portion that appears linear. The nice thing about these two things is you don't really have to linearize the data yourself. If it's going to become linearized and manipulated algebraically, they'll probably do that on the AP test for you. So we're not going to cover how to do that. Just know that it could happen. Like they could give you an equation with like a log in it or something like that. All right, so when we graph our relationship, just like we did in Unit 1, once we've got our data, we graph it. Well, we're going to do the same thing with bivariate data. It's just that our graph is going to look a little different. We're not going to have lots of different options for graphs like histograms and box plots and all of that. We're going to have a scatter plot, and it's just going to be little dots on your XY coordinate plane. That's it. All right, so it's still important that we use good communication all the time. We do need to label our axes, and by that I mean we'll just label X and Y based on what they are in context of the problem. So they will be X and Y, but we'll put the actual names in the graph. But when we sketch, our dots for our scatter plot, we don't have to label X and Y. All right, we don't have to put numbers there. We're just throwing the dots up. That's all we're doing. So we're going to look at some pictures of different types of relationships. So of course my x-axis and my y-axis, a perfect positive relationship is a line, just like that. A strong positive relationship would be something like this. Okay, that's a strong positive relationship. A weak positive relationship might just have more of a scattering of your dots, all right? But, let's get rid of that one. That's not. Okay, so they're going to be a little bit more spread out, but still trending in the positive direction. Okay, so what would a weak negative linear relationship look like? Well, I've got X and Y here. A negative weak relationship, of course, would look something like this. So see, they're trending in the negative direction, but they're kind of scattered. They're not really tight together. So a strong negative linear relationship would look something like this. So again, they're trending to the left upwards like this, like a negative line would, but then they're more tightly packed. So that gives you a stronger negative relationship. All right, and of course a perfect negative linear relationship would be just a line of dots all in a line, just like that. And then no linear relationship. Well, this is just a cloud of points. That's all it is. It's not really trending anywhere. All right, it's just, they're all over the place. That's what no linear relationship would look like. So as you're talking about, okay, what kind of relationship do I have? How strong is it? That's kind of how you can tell. And it really is kind of based on, if you're looking at the scatter plot, you really do have to base it on, okay, well, what does that look like? It's not, you are going to rely on the math, but you're also just going to be looking at the scatter plot too. So once we have the graph, well, guess what? A description of the relationship is still going to be with us just like it was in Unit 1. Remember, we cussed and BS'd about our distributions, CUSS, and then we were as specific as possible, including our context. We're going to do the same thing here. It's just that these things are going to look a little bit different. So for this one, we're going to use SUDS. All right, so we're going to talk about the shape. Your options are that it's linear or not. You don't have to go all out and say, oh, it's cubic or quadratic. No, don't bother with that. It's either linear or it's not. Unusual features, we're still going to have outliers. Direction, is it positive or negative? Strength, is it strong, is it moderate, is it weak? Those kinds of things. And I'll give you more guidelines for that as we look at examples. Okay, so outliers. Is there a test for outliers with bivariate data? No, good news. You just have to eyeball it. If it looks like it's outside of the pattern of the other points, guess what? It's an outlier. So what would that look like in a scatter plot, Miss Griggs? Well, let's say we had something like this. I'd call this a weak positive relationship. And oh, look, there's our little outlier right over there. See? He's an outlier. And it is a judgment call. If it doesn't go along with the rest of the trending of the data, then guess what? It's an outlier. So we're going to talk more about outliers in the next video because I need to talk to you about whether or not it's influential, and that's going to take some time.